Good day to you. This is teacher Leland, Alejandro, and we're going to discuss today graphing absolute value functions. We're going to see the worksheet after a little while in the other screen. Let us check. Okay, this is the worksheet for absolute value functions. These are lecture examples. So we're going to do graphs about absolute value functions. This will be about how many problems? Let's check. This will be about 8. Yes, there will be about 8. Okay, let's start with the first number using the presentation view. First number, graph each equation. Here's the first. Y is equal to absolute of x minus 2. So we're going to do the graph for this, and we shall determine the vertex of the graph first. So the graph of the absolute value function starts with 1 point and goes to one side of that and goes to the other side. So it's symmetrical with respect to the point, okay, or the line or the vertical line passing through that point. So we shall check. We shall check, okay. All right, and when the value of x, what makes the x uh, 0 in this particular equation? All right, we have absolute of x. We only need to get the expression inside the vertical bars and then set this to 0. And so if you do this, you're going to have here like setting x to 0, which is right away 0, okay? And when x is 0, what will be the value of y? Okay, that's the next question. If x there is 0, then we have 0. Absolute of 0 will still be 0. And so we have 0 minus 2. Well, that should be a negative 2. So we have our vertex at point 0. This will be the vertex. The vertex is located at 0, negative 2 there. So this will be the beginning point. Now, at the neighborhood of 0, we can take on the next value, say positive 1 and negative 1. All right. So what will be the value of y when x is 1? Okay. So when x is 1, then we're going to have the absolute of 1, which will give us 1 minus 2, which is negative 1. Okay. So the next point is like this. So if we have x here and we have the y and the lower part, we can do some points here, okay? So when the value is, say, to the right of 0, then it's 1. And then use the equation there, okay? Use the equation there to compute. And so if we do that, we will have, of course, y is equal to absolute of 1, okay? It's like this, and then minus 2. And absolute of 1 will still be a positive 1. Then minus 2, that should result to a negative 1, okay? That should be a negative 1 like that. And this will be the value of y. So the value here must be negative 1 there. All right, so how about another value? How about another value to the left of 0? Okay, to the left of 0, then we shall use the same equation. What's the value of y? Okay, all right, let's start here. What is the value of y when x is negative 1? All right, this will be negative 1 now inside the vertical bar, and we still have that minus 2. All right, the absolute of negative 1 will still be a positive 1. Minus 2, that results to another negative 1. And so we can now place something here. When x is negative 1, then the result is also negative 1 there. How about another value to the right of the positive 1? Okay, to the right of the positive 1, that will be 2. Okay, so we shall try to put here 2. Okay, and then let's compute using the same equation. y is equal to the absolute of 2 minus 2, then we shall have something like 2 minus 2, which results to 0 there. And so the value here will be 0. Okay. How about a point, a value of x to the left of negative 1? That will be a negative 2. So we shall use a value negative 2 for x, and then compute for the value of y. All right, so let's make use of the given equation again. This is absolute of negative 2 minus 2. This will still be 2 minus 2, which will still give you 0. Okay, and so the value here is again 0 there. Now let's have another value of x to the right of 2. Okay, the positive 2. That will be a positive 3, and we shall put it here. There. Now use the equation again. Use the equation again, and we shall do it over here. Let's just put a fence over there. We shall use the same. Y is equal to vertical bar. Our value of x is 3, and then we still have that minus 2 there. This becomes 3 minus 2, which results to a positive 1 there. And so the value here of y, the value of y here is 1. Okay, like that. Next, to the left of negative 2, okay, to the left of negative 2 is negative 3. So we shall use another value of x, negative 3, and use the equation again. Y is equal to absolute value of negative 3, like this, and then minus 2, and this will still be 3 minus 2, which results to another positive 1. And so we were able to compute the coordinates of our graph. Okay, you can see our table here. All right, you can put some lines here so that it will look like a table. All right, such as this. And how about the next one? Okay, you can see now the pairs. Okay, this is one pair. There. So we have a point at 1, negative 1. Okay, our vertex is at 0, negative 2. Okay, so where is 0, negative 2? 0, negative 2 is over here, our point. Okay, we have a point over here, 0, negative 2 there. Okay, and so we have some points at 1, negative 1. Okay, we're talking about this value here. We're talking about the point here. Our x is 1, our y is negative 1. 1, negative 1. So that is located somewhere here. There. Okay, that's 1, negative 1. The next point is negative 1, negative 1. The next one. This is negative 1, negative 1. That should be at the third quadrant over here. And then the next point is 2, 0. Our x is 2, our y is 0. So it's 2, 0. It's over here. There. And the next point is negative 2, 0. I'm talking about this one. Negative 2, 0 is right here. There. And then the next one is 3, 1. Okay, this will be at the first quadrant. This is 3, 1. Okay, there. And our final computed point is negative 3, positive 1. So negative 3, positive 1 is over here. Now you can just imagine the graph now. Okay, looking at this series of points. Okay, this means we have our graph like this. I'm going to connect the points now, like that. And the other one, of course, like that. And so this must be the graph of the function. Okay, all right, and let's see how it looks like, verifying this by the computer. There, okay, all right. So the computer's answer is coinciding with our drawing. So you cannot let me erase our let's erase our graph so it can display its own. All right, let me erase it. Let us just retain the points. Okay, the points are still there. Okay, let the computer display its answer there. Okay, all right, so it's correct. All right, so that goes to our first number. So all you need to do is generate some points and you'll be able to draw your graph starting with a vertex. Okay, starting with a vertex. All right, so next we're going to do the second number. Let me clear the screen. Let's proceed to number 2. Okay, here's number 2. All right, we shall going to start with the expression inside the vertical bars, the x plus 3. That's where we start. Okay, so that's where we start. X plus 3, equate this to 0. And then we shall solve for x. Okay, what's the value of x here? So we shall do this by way of subtracting the 3 from both sides, like that. And so we will have the left side of the equation x, and the right side is negative 3. There. Now we found the x, the required x for the vertex. Okay. Now, what is the value of y when x is negative 3? Okay, so we shall use this now. And this is the equation. Y is equal, we have that vertical bar x plus 3, vertical bar minus 1. Okay, we shall now use the negative 3. So we have here y is equal to vertical bar negative 3 plus 3, vertical bar minus 1. And we have something like y is equal to vertical bar 0 minus 3. Make that minus 1, all right? Because negative 3 plus 3 is already 0, so we have 0 minus 1, which results to a negative 1, okay? So our y coordinate is negative 1. So we found our vertex, okay? This is our vertex now. Our vertex is at negative 3, negative 1, there. And so our x is negative 3. All we need to do is get some value of x to the right and to the left of negative 3. Okay, so we can choose any value within our graph. Okay, all right. Do not choose 100, of course, because our graph is limited to 6 by 6 there. Okay, all right. So we can choose, say, negative 5 and a negative 1. Okay, that's 2 units to the right and to the left. Okay, let's start with negative 1. Okay, what is the value of y? Going back to our equation, okay, y is equal to absolute of x plus 3 minus 1. All right, what is the value of y if we choose a negative 1? That's 2 units to the right of negative 3 from the vertex. Okay, all right, let's say our value of x is negative 1, and then we have to add 3, and then that absolute value of that minus 1. All right, this will result to absolute of 2 positive, and then minus 1, which results to 2 minus 1, which is simply 1. Okay, all right, there. And so we found a point. Okay, this is now our point. When x is negative 1, then our y is a 1 there. Okay, now we shall use the value of x. I said a while ago it's a negative 5. That's to the left of negative 3. All right, so we will use the equation again. Say y is equal to x plus 3 minus 1. Okay, we shall choose now the negative 5. Say y is equal to absolute value of negative 5 plus 3, okay, minus 1. All right, we shall have something like absolute value of negative 2 minus 1, which results again to simply 2 minus 1 there. Okay, and so that results to a final value of 1. And we have our next point. Okay, when the value of x is -5, then our y is a +1. And we now have 3 points we can use to draw our graph. Okay, and this will be enough. Okay, all right. Our vertex is located at -3, -1. So that should be the third quadrant over here. Okay, -3, -1. Our second point, that will be -1, 1. Okay, it will be at the second quadrant over there. And then our third point, -5, 1, is also at the second quadrant here. All right, these 3 points will be enough for us to draw it. All right, I'm going to draw our graph. All right, starting from the vertex, it should be like this. All right. Okay, and on the other side, it's over there. All right, there. Okay, this will be our answer. All right, let us check from the computer. Okay, there. Okay, you can see some parts blinking because the computer cannot display because our drawing is there. Okay, so I'm going to erase our own drawing and retain our 3 points. All right, the 3 points are still there. Okay, and let's show the computer's answer. It should coincide with our points there. Okay, all right, that's the computer's answer there. All right, so our solution is correct and our graph is correct. We shall continue with our third. Let's go to our third. This is now number 3. All right, graph each equation. Y is equal to 3 times the absolute value of x plus 1 minus 1. All right, again, we shall start finding the vertex first. All right, we shall get the expression inside the absolute symbol, absolute value symbol, and that's x plus 1. We shall begin there and equate that to 0. The expression, equate this to 0, solve for x. All right, so this is a very simple equation, linear equation. So we subtract 1 from both sides, like that, and we will have something like this. And x is found, and this is supposed to be 0 minus 1, which is a -1 there. This will be our x. We will now use this value of x and use the equation, the function, okay, to compute for the y coordinate. All right, so we shall begin with the equation. Y is equal to 3 times x plus 1 and minus 1 there. We will now use the -1, okay? We shall now use our x value, okay? This value here, and use it in our equation. So we will have y is equal to 3 times, okay, the absolute value of -1 plus 1 minus 1, all right? And we obtain how much? This will be 3 times 0, yes. 3 times 0 minus 1, which is just 0 minus 1, okay? Like that. And we have a -1 as answer. And this will be our vertex, okay? So our vertex is located at -1, -1 there, okay? Now we need 2 points again. All right, now we shall choose, say, 2 points, okay, which will be 2 values of x, okay, and 1 value of x to the right of -1, and another 2 units to the left of -1. So again, we can choose, say, +1, okay, +1. That will be 2 units to the right of -1. So let's say when x is +1, say at x equal to a +1, what should be y? All right, so we go back to our equation. Y is equal to 3, and then we have x plus 1, like that, -1 there. This is absolute. All right, and so we shall compute using x +1. So this is like 3 times 1 plus 1, okay, minus 1 there. And this will be 3 times absolute of 2, like that, minus 1. And this continues 3 times 2, okay, minus 1, which results to 6 minus 1. You see, we're going to have it in detailed. All right, so this will be 6 minus 1, which is 5. So y is equal to 5 there. And we have our point. When x is 1, a positive 1, our y is 5 there. Okay, now we shall do another. All right, this time to the left of our vertex value of x, which is negative 1. All right, so 2 units to the left of this will be at negative 3. All right, so we shall compute the x value negative 3. So at x equal to negative 3, what is our y? All right, we begin again with our given function 3 absolute of x plus 1, okay, minus 1. And so we continue with y is equal to 3 times negative 3 plus 1 minus 1. And we have y is equal to 3 times, that results to absolute of negative 2 minus 1, which results to the same, okay? 3 positive 2. 3 times positive 2 minus 1, which will still give us a 6 minus 1, resulting to a 5. And so our y is again positive 5. And so we can see the symmetry. And at x equals negative 3, our value is again positive 5. And these 3 points will be enough for us to draw it. We found the vertex at negative 1, negative 1. And so we can start plotting our graph. Let us begin with negative 1, negative 1. It's located at the third quadrant over here. I am now putting the point. And then our second point is at 1, 5. So 1, 5 will be up here. And our negative 3, 5 will be up here. There. All right. And so we can now connect these points. This will be our graph. There. Like this. All right. And this is the required graph. And we can verify that from the computer. There. See how the computer draws the answer in place of our answer there. Okay. All right. The computer's answer is with the arrow. Okay. Ours is without. All right. And so we shall erase our answer and just retain the 3 points and let the computer display its own. There. Okay. All right. So we're correct. And so this goes to our number 3. We shall continue with number 4. Let me clear the screen. Let's go to number 4. All right, this is number 4. Graph the equation y is equal to 3 times x minus 1 plus 1. Again, we shall begin with the expression inside the vertical bars. Okay, and so we have there x minus 1, and then equate this to 0, solve for x. Okay, all right, so we will be doing this by way of addition property. Add 1 to both sides of the equation. And we will get the value of x equal to 0 plus 1, which is just 1, okay? And so we will now use the equation to find the y value for x equal to 1 so that we will find our vertex. So this is now x minus 1 plus 1 there. Let us now substitute the positive 1. This is now vertical bar. This is 1 minus 1, and this is plus 1. And so we will get 3 times 0 here. So this is just 3 times 0. There's an equal sign there. And this is plus 1. Our value of y is, of course, positive 1. And so our vertex is located at the first quadrant at 1, 1. And this is 1, 1, like that. Okay. All right. Coming from our computation, this will be the vertex. Now let us use 2 points, and we will use again 2 units to the left and to the right of the positive 1 value of x. Okay. And so we shall choose 1 plus 2 is 3. All right. So we shall make use of x equals 3. So we shall compute over here. So at the value of x equal to 3, okay, at x equal to 3, we use the equation. We have 3 times vertical bar x minus 1 plus 1. And so we substitute our 3. Y is equal to 3 minus 1. That's inside the absolute value symbol plus 1. So we'll just compute this. This is 3, and this will now be absolute of 2 plus 1. And this continues with 3 times 2, that will just be 6 plus 1. So 6 plus 1 is 7. There. And so our first point is 3, 7. Okay. And so this won't be in our graph. Okay. But we can do an approximate of that. Okay. Where is 3, 7? Where is 3, 7? If we're going to draw that, that will be 3 and up here, somewhere here. Okay. Outside our given graph right there. Okay. But then let's use that. Okay. Now let's reduce our or we can still continue with a value to the left of the positive 1 that we obtained. Okay. And that will be at negative 1. Okay. All right. That will be the other point. Yes. Just like what I said, it's 2 units. 2 units to the right of 1 is 3. Now 2 units to the left of 1, and that'll be at negative 1. So we shall compute with the negative 1 value. Okay. This will be at x is equal to negative 1. We still have the same equation. Y is equal to 3 times the absolute value of x minus 1 plus 1. And so we continue. Y is equal to 3 times, and then that's a negative 1 minus 1 plus 1. This gives us 3 times absolute of negative 2 plus 1, and this results to another 3 times positive 2. The absolute of negative 2 is a positive 2. That results to 3 times 2, 6 plus 1. So this will be again 6 plus 1, and we will get another 7. Okay. And so our point here is negative 1, 7. Our second computation is 3, 7 over here at the middle. This is 3, 7. Okay, there. All right, so these are our points. Our vertex is at 1, 1 over here. There. And our second point is at negative 1, 7. So it must be up here. Okay, there. All right, it's outside our given graph. Okay, all right, but we can do an approximation and draw it and see how the computer will provide the answer. All right, if I should connect it like that, and also this one. All right, let's see how the computer connects. All right, the computer is still there. The computer's answer is within our answer, okay? Only our answer is larger. All right, we should have chosen just positive 2 for x and a 0, okay? That's 1 unit to the right and to the left of our x equals 1. All right, but just the same, our answer is the same as the computer's. Let me clear our graph and let the computer draw its drawing, its graph, its answer. All right, there. Okay. All right. Okay. Just the same, we have our graph. All right. So if you have a larger graphing paper, okay, you can include the -1, 7 and the 3, 7. All right. Okay. So that's it. Let's compute and do number 5. Okay. Here's number 5. And we have a simpler equation. Y is equal to 2 times the absolute value of 2x plus 1. All right. Let's have the solution. Again, we shall begin with the expression inside the vertical bars. That's 2x. And equate this to 0. And then solve for x. All right, so the way to find x here is start with division. So 2x is equal to 0. We shall divide both sides by 2. And the right side by 2. And we put a divide there. Okay, this is divide. Also, this is divide. Our x is 0 here. So our x is 0. Okay, next we'll find the y value using the given equation. Y is equal to 2 times the absolute value of 2x plus 1. Using now our x, which is 0, we have something like 2 times 0 inside the vertical bars plus 1. And so this continues like 2 times 0 plus 1. So y is equal to 2 times 0 plus 1. And so this is just 0 plus 1. And we have our value 1 for y. There. And we found our vertex. This is where the graph starts at 0, comma 1. Okay, there. That's the vertex of the absolute value function graph. Okay, now we need 2 points. Okay, all right. Our x is 0, so we shall choose 2 units to the right, of course, and we'll be able to draw. All right, to the right of 0, we will have to choose 2, the positive 2. All right, we shall choose here. All right. Let's have the value here at x equals to positive 2, and then we shall select another value of x to the left of 0. That would be -2. Okay. All right. So we shall place another fence here and then put that value so that we will be ready after a while at x equal to -2. That will be our next value of x. Now, just the same, we will be using the same equation. Y is equal to 2 times, all right, absolute value of 2x plus 1. Okay, and so we will use now positive 2 for x. So we have 2 times absolute value of 2 times 2 there plus 1. Okay, and so this looks like 2 times absolute of 4 plus 1. And this will be, all right, what do we have here? This looks like, this will result to something outside our graph. Okay, this looks like a 9. Okay, let's lessen our value, say just 1 unit. Okay, all right, let's use a different value because this will result to a point outside our given graph range. Okay, all right, let's use something else. All right, let's choose just positive 1. Okay, at x equal to say positive 1 and -1. Instead of 2 and -2, let us change our x so that we will have uh, a value of y in our range. Okay, in our range. All right, so let's change that. All right, so this will be at a value x at x equal to 1. I figured out it will give us 9 and our range is 6 by 6 only. Okay, so instead of using 2, let's use 1 and -1. Okay, the other will be at x equals -1. All right, and then let's just erase this part here. Okay, we're going to change this. All right, we shall make use of y is equal to 2 times absolute value of 2 times 1 there, and this we will fit, okay, inside our given graph. And so this will be y is equal to 2 times absolute of 2 plus 1 there. And this looks like just 5, okay? And so this fits. This will be 2 times 2 plus 1, and that really results to 4 plus 1, which is 5, okay? So this is 4 plus 1, and so y is equal to 5. There you are. Our computed point is at 1, 5, okay? 1 for x and 5 for, okay, let's type it. This will be 1 for x and 5 for y, there. And 1, 5 is inside our first quadrant, all right? Next, let's use the negative 1. This will be y is equal to 2 times absolute value of 2x. Let's write the equation first and then plus 1. Okay, let's compute. See, let's find out, and we will have, let's see if we will have a symmetry. This is 2 times negative 1, okay? 2 times negative 1 plus 1. And next line will be y is equal to 2 times absolute value of negative 2 plus 1. And of course, absolute of negative 2 is a positive 2. Yes. So we will still get 2 times 2 here plus 1. And we have 4 plus 1 again. And so we have a 5 again. And our computed point, negative 1, positive 5. So negative 1 and positive 5. Here's our point. We have a negative 1 and a positive 5 there. All right, so that's it. All right, let's draw our graph. And let's begin with our vertex 0, 1 is right here, okay? And our second point, computed point, is right here. There. And our third point is at negative 1, 5. It's over here. All right, there. Okay. All right, now we shall connect this using straight lines. And this is our graph. There. Imagine if we have used 2, we are going to have 9, okay? And that point will be somewhere here. 2, and this will be 7, 8. This will be somewhere here, okay? And if we have used negative 2, that will still be negative 2, 9. That will be up here, okay? There, because it's, this will be 6, 7, this will be 7, and then 8, and then this is the 9 level, so this will be negative 2, 9. It's somewhere here. See, I'm trying to approximate it. So you see, if we have chosen the positive 2 and the negative 2, if we have continued doing that, we will have our points outside the given grids, okay? And so I have replaced it with 1 and negative 1, which fits inside, okay? And so we don't have to do that, okay? And so we will just we will have to use our computed values now. All right, there. And this is our answer, okay? This is the graph. And let's verify the computer's answer. There. All right, there's the computer's answer, and it matches our answer. The computer has the arrows, okay? And our drawings don't. All right, so that's the only difference. All right, okay. And so if we shall erase our straight lines there and just retain the points and let the computer display its graph. All right, there's the computer's answer. Okay, it matches our own drawing. Okay, all right. So the 3 points that we have computed are there. The vertex and the other 2 points, okay, provides for our graph. Okay, all right. So that's it for number 5. Let's continue with number 6. All right, let me clear the screen. And this is now number 6. All right, so this we have y is equal to 2 times 2x minus 3. Again, we will begin with the expression inside the vertical bars. So let the expression be equal to 0 and compute for x. So this will be divided by, of course, the number beside the variable. So this will be both divided by 2. So this is divided by 2, and the other one is also divided by 2, which results to x equals to 0. So this will just be x equal to 0. Compute now for y using the equation. Okay, our equation is equal to y is equal to 2 times the absolute of 2x minus 3. And so y is equal to 2 times the absolute of 2 times 0 minus 3. We have something like 2 times 0 minus 3. So y is equal to 2 times 0 minus 3. And this results to 0 minus 3, which is simply negative 3. There. So our vertex is located at 0, negative 3. So this will be our vertex. It's 0, negative 3. This is our x and y coordinate for our vertex. And that should be located right away. And this will be 0, negative 3. It's down here below the origin. There. Okay. That's 0, negative 3. Now we need 2 points. Okay. We need 2 points to the left and to the right of 0. Okay. All right. So we shall make use of the spaces at the right side, and we shall choose our values. Let's say we use 2 units to the right of 0. Will that be a good? All right, let's see. If it's 2, then let me approximate. That's 4 and 2, 8, 8 minus 3, that looks like a 5, okay? And if it's negative 3, make that negative 2, it's 4 and 2, 8, 8, it's a 5. Yeah, it will fit. All right, let's make use of 2 units to the right of 0. All right, at x value equal to positive 2, okay, we're now going to use 2 units to the right. At x is equal to positive 2, and the other one at x equal to negative 2. There, all right. And we shall make use of the equation at this point. So this is y is equal to 2 times the absolute of 2x minus 3. What will be the value of y? So this will be 2 times 2 minus 3. And this computes to 2 times 4. Okay, 2 times the absolute of 4 minus 3, which results to 8 minus 3, which is 5. There. And we have our second point, 2, 5. This will be our second point, 2, 5. Now let's continue with x equal to negative 2 using the same equation. Y is equal to 2 times absolute of 2x minus 3. This will be 2 times the absolute of 2 times negative 2. 2 times negative 2 minus 3. Absolute value. This will be 2 times absolute of negative 4 minus 3. And we have y is equal to 2 times 4 minus 3. And we have 8 minus 3 again. So this is y is equal to 8 minus 3, results to a positive 5. There. And so our third point is negative 2, 5. This is our third point. Now we're ready to draw our graph. Our second point is 2, 5. That should be inside there. And our other point is on the other side, negative 2, 5 there. And so if we draw our lines, okay, this will be from 0, negative 3, the vertex. We project it up there, okay, and then also the other, we project it up there, okay. All right, so that's it. The computer's answer is with the arrow. Watch and see. There, okay? All right, so you can see the computer's answer coinciding with our drawing. All right, there. I'll make it blink there, okay? And so this is correct. Let's proceed to number 7. Let's clear the screen, clear the answer. Number 7 now. Okay, here's number 7. This looks rather simple. X is equal to 0 right away, okay? Because we are supposed to equate the expression inside the vertical bars to 0 and solve for x. And so this is x equal to 0. That's it. That's the value of x. And we can evaluate right away what's y. And so from the equation, we have y is equal to negative absolute of x plus 1. And so we have a negative 0 plus 1, which is still 0. So we will have 0 plus 1 here, which gives us a positive 1 value for y. And so our vertex is 0, 1. So our vertex is at 0, 1 there. We shall now find our other 2 points. Okay, we shall have our other 2 points at the right side, okay, of the screen. All right, so we shall choose values to the right and left of x equal to 0. Okay, let's see if it will fit, okay? If I choose 2 here, that should be, yeah, that looks fit. All right, all right. So let's make use of x equals 2, x equals 2, and the other one, let's choose x equal to negative 2, okay? All right, and see the answers. All right, so this will start with the given y is equal to negative absolute of x plus 1, okay? There, our given function. Compute for the value of y when x is positive 2. So this is like this, plus 1. And so we will have something like negative 2 plus 1, and results to negative 1 here. So y is equal to negative 1. So our second point is located at 2, negative 1. Positive 2 for x and negative 1 for y. And we shall compute our third point. This will be y is equal to negative absolute of x plus 1. This is negative of absolute of negative 2 plus 1. And this will still be a negative 2, okay? So this is negative of absolute of negative 2 is a positive 2, but there's a negative 1 presiding it. So therefore, this will still be negative 2 plus 1. And this results to a negative 1 again. So y is equal to negative 1. And so our third point, this is negative 2, negative 1. There. And we're now ready to draw our graph starting from the vertex 0, 1, which is located just above the origin. There, you can see the red point I'm making there. And then our second point is positive 2, negative 1. So that will be 2, negative 1. That is at the fourth quadrant there. And the negative 2, negative 1 at the third there. And so we're ready to draw our graph. Let's use straight lines there. And use another one the other side. All right, so there you are. Okay, this is our absolute value function graph for number 7. Let's check and verify from the computer. There, all right. Okay, our line should be drawn slightly tilted. Let's redraw that left side, okay? Let's redraw that. Looks like there was an inaccuracy there. All right, let me draw it once more. This is the 0, 1 connecting with the -2, -2, -1. Let me redraw that again. I want it a little perfect. All right, so 0, 1 is right here. Okay, and then we will connect it to the -2, -1. All right, so extending it over there. All right, I hope that fits already. There, okay, let me verify again. All right, there, okay, that fits already. Okay, yeah, okay, you can see the arrows now. There, that will be for the computer's answer. There, all right, it fits our drawing now. Okay, there, okay, all right. Because I made the point slightly larger, and when you try connecting them, if your point is too large, then you might have a little error there. Okay, all right. Now, how to draw your lines perfectly? All right, this is how to do it. You don't have to make the points very large. Okay, all right. Let's redraw that. I'm going to show you how to do it. All right, let me erase our 3 points and make the points small. Okay, that's the technique. Okay, if you will make your point small, okay, then you will have an accurate drawing. All right, let's say our point is 0, 1 there. Okay, our 2, -1 is over here and there. Okay, 2, -1. How about the -2, -1? All right, over here. I'll just make my point very small, like that. Okay, and we will have a very accurate drawing. All right, this is how to do it. All right, it's over here. Okay, all right, there. Okay, so that's it. And the other one, because if you make your points large, it will send you an error there because it's large. Okay, if you have a small point, okay, you can have a very accurate drawing there like that. Okay, all right, watch and see. There, see? All right, the computer's answer does not show any difference with our drawing there. Okay, all right, that's how to do it. Don't make your point very large, but for the sake of explaining it to you, okay, I have to make the points larger. Okay, that's why. All right. Okay, so that's it for number 7. Let's do number 8. Do we have number 8? All right, let me clear the screen. Let me erase the answer. Let's proceed to number 8. All right, here's number 8. All right, y is equal to negative the absolute of x minus 3 plus 4. All right, again, we will start with the expression inside the absolute value symbol. So we have x minus 3. Equate that, x minus 3, equate this to 0, and solve for x. So we will do by addition property. We shall add 3 to both sides. And so we will have our left side just x. Our right side will be 0 plus 3, which results to a positive 3. That will be our x. Now, we're going to use this in our equation. Solve for y. So this is negative of the absolute of x minus 3 plus 4. There. So use now the value 3 in our equation. So this will be absolute value of 3 minus 3 plus 4. There. And so we have y is equal to negative 0 plus 4. And so that will simply be 0 plus 4. Because there is no negative 0 or positive 0. 0 is neutral, okay? So that will be 0 plus 4, and that is equal to 4. And so our vertex, that's located at 3, 4, okay? 3, 4. So this will be our vertex at 3, 4. All right, so the location of this is above, okay? So it will be over here, okay? If I should draw the point it will be 3, 4 right here. Okay. Again, I will make the point larger so that you'll be able to see it. All right, there. That's 3, 4. That's our vertex. Now we need 2 points to the right of x equal to 3. And we shall do that over here at the right side of the screen. All right, so let's just put fences there for our 2 points. All right, and then we shall choose a value of x to the right of 3. Now, to the right of 3, we shall choose just 4. Okay, at x equal to 4, and the other one will be say 2. Okay, to the left of 3. So at x equal to 2 there. All right, and then use the equation using these values to solve for corresponding y values. All right, so we will write the equation again. Y is equal to negative of absolute x minus 3 plus 4, and we shall compute. This is now negative of the absolute of 4 minus 3 plus 4. This continues with negative absolute of 1 plus 4. So this means we will have here a negative 1 plus 4, which results to 3. And our value coordinates of our second point is 4, 3. This will be 4, 3 there. Okay, and 4, 3 is located somewhere here, just beside it there. Okay, that's 4, 3. All right, let's continue with our third point using x equals 2. Our equation is still y is equal to negative absolute of x minus 3 plus 4. And so this is y is equal to negative of absolute of, this time our x is 2 minus 3 plus 4. And this results to y is equal to negative of absolute of negative 1 there plus 4. And we will still get negative 1 plus 4. And this results to 3, a positive 3. And so our third and final point will be 2, 3. And this will be located at the first quadrant also. Okay, and where is 2, 3? 2, 3 is somewhere here, there. All right, there. Okay, let me draw our line. All right, so, all right, let me draw it. And this must be just this. All right, let me draw it there, and the other one, of course, this will be extended downwards. Okay, this will be all right. Let me passing through all the grid points, intersection of the grids there. All right, that's it. All right, so let's let the computer show its answer. This is our graph. Okay, all right, there is the computer's drawing. Okay, you will notice the arrows being added. Okay, because the segments are with our segments too. Okay, all right, there. All right, okay. Okay, so if I should erase our own drawing and let the computer display its own, you'll be able to notice it. All right, there. Okay, here it goes. You will see the computer's answer passing through our 3 points. There, okay, all right. Okay, all right, there. Exactly where we placed our lines a while ago, okay? Okay, so that shows our 8th example, and I think this is the last example. Okay, all right. And so I hope you were able to learn from the method, and draw your own graphs. Okay, and this will be all for now. See you later for another discussion. Okay.